In the field of health and medicine, the ability to predict variables such as the spread, mortality rate, and number of infections plays an important role in disease management.
Throughout centuries, the measles has persisted as a threat, notably affecting children under 5 years old and adults over 30.
In this context, the fundamental question that our research will approach arises. Can machine learning techniques be employed to accurately predict the total annual deaths produced by the measles occurring globally?
Our proposal is to explore how artificial intelligence can predict the number of deaths with precision by adjusting parameters like the degree of the polynomial function used in the prediction and quantifying the margin of error in each experiment with the objective to identify the most accurate model.
Our general objectives of our research are
To analyze and process historical data related to measles deaths since the year 2000.
To explore various machine learning algorithms and models to accurately predict the total number of deaths caused by measles.
to evaluate different functions that enable obtaining more accurate results to generate a successful prediction.
To achieve our goal, it's important to understand measles, that it's a highly contagious disease that has been responsible for many deaths, although vaccines have reduced its impact. Measles spreads through sneezing, coughing, or direct contact with the person infected. They can lead to serious illnesses like pneumonia or a neurological damage. Organizations like the World Health Organization and the Pan American Health Organization play important roles in addressing to these.
The first is NumPy, or numerical Pythons. This allows us to make complex equations.
Secondly, as a complement, we have Matplotlib. This library is used for data visualization and includes a wide variety of graphs, and it is compatible with data created by NumPy.
However, to analyze and understand how accurate the prediction is, we need to know what the mean square error is. It is used as a measure that is calculated as the mean of the squares between the real values and the values predicted by the
The
system.
degree of a polynomial is represented by the exponents. These are the integer rational values and affect the variable. Higher degrees in polynomials means that they have a larger number of terms, allowing for more precision in fitting the data, allowing patterns to be captured.
Taking a general view of the code, it can be summarized in that it takes the given values for x and y and then with the degree of the polynomial creates an equation that resembles the given values in order to create the prediction for the requested year. In this case, we tried several degrees of the polynomial and then created another code that allows us to understand the relationship between the degree of the polynomial and the mean square quadratic error, and we obtain an inversely proportional relation. Code shows that between the polynomial degrees since 1 to 70, the one closest to the real value for prediction is 4.
We saw that the resources we used in our methodology were accurate, since knowing how to handle the programming codes to adapt them to our data and prediction was important. Furthermore, we have to take into account the behavior of measles, since we know that the behavior of an infection is not easy to predict due to different factors such as vaccines.
It is for this reason that although the accuracies are supposed to be more precise with higher polynomial degree, we saw that the polynomial degree number 4 was the correct with the final prediction, and not the highest as we could see in the 70, which had a MSE of 393.1, the smallest and the best suited to the data. However, the result to predict did not have a uniform behavior, and this is why number 4 was more accurate. Finally, we can conclude that it's possible to make predictions about the behavior of infectious diseases such as measles. However, the accuracy of prediction with a basic code is not so exact. We could see that our result for 2010, the closest value and the closest prediction was a polynomial degree of 4, with a deviation from the 2000 to 2009 data much larger than degree 70, but with a closer prediction